boys and girls. In this video, we're going to take a look at how to compare fractions. I'm starting with fractions that have common denominators. So I've drawn two models up here for you, and I've divided both models into 4 equal parts. In the first model, I've shaded in only one of those parts. In my second model, I've shaded in 2 of my 4 parts. And I think by looking at the model, you can see which fraction is the larger fraction or which model has a bigger piece shaded in, right? Obviously, the 2/4 is bigger or more is shaded in than the 1/4. So we can draw a conclusion about fractions that have a common denominator. My common denominator here is 4. We have different numerators, 1 and 2, and we can say the more parts you have, the bigger the fraction. In other words, 2/4 is greater than 1/4 because I have more of my model shaded in. Or another way to say that same statement is 1/4 is less than 2/4. So again, when we have common denominators, it's pretty easy to determine which one is the bigger fraction. The more parts you have shaded in, the bigger the fraction. And you can think about it in terms of pizza pie. If you have a pizza pie that's cut into 4 parts and you only eat one piece as opposed to 2 pieces, when are you eating more? You're eating more when you eat 2 pieces. Okay, let's move on to our next thing that we want to look at when comparing fractions. So what about when we have common numerators? Notice in my models here, my common numerator is 1, but my denominators are different. Again, I've drawn 2 models. My first model, I've divided my model into 4 equal parts. And in my second model, I've divided my model into 8 equal parts. My numerator's the same. I've shaded in 1 out of 4 for this model. I've shaded in 1 out of 8 for this model. So can you tell me which fraction is the larger? Well, let's think about pizza pie again. If I get a pizza pie and I cut my pizza pie into 4 equal parts, and then I have another pizza pie and I cut that into 8 equal parts, which pieces are smaller? The pizza that I've cut into 8 equal parts. So now we can draw a conclusion about when we have common numerators. The conclusion, the smaller the denominator, I've only cut it into 4 parts, the bigger the fraction. So 1/4 is greater than 1/8. Or I could say it the other way, 1/8 is less than 1/4. So we've drawn 2 different conclusions. When we have common denominators, the bigger the numerator, the bigger the fraction. When we have common numerators, the smaller the denominator, the bigger the fraction. So now let's move on. My next example is when we don't have common numerators or common denominators. Now what do we do? So my 2 fractions that I'm looking at, 2/4 and 5/8, it's not really a good idea to draw a model for these 2 fractions because if you don't draw your models perfectly, it might be very hard to really distinguish which part is bigger. So we have to use some other strategies, but we're going to draw on those conclusions that we just went over, and we're going to draw on other things that we know about fractions. So let's look at 2/4 and 5/8. Do you see any of those numbers that are related to one another? Take a minute. Well, you should recognize that 8 is a multiple of 4, or another way to say that is 4 is a factor of 8. So can I write an equivalent fraction for 2/4 that would have 8 in the denominator. Can I find an equivalent fraction for 2/4 that has 8 in the denominator? Well, I think I can, because I know 4 times 2 is 8. And remember, for equivalent fractions, whatever we do to the denominator, we do to the numerator. So now 2 times 2 is 4. And I see that an equivalent fraction for 2/4 is 4/8. Now, can I compare 4/8 compared to my 5/8? Well, I can go back to that conclusion that we drew about common denominators. Remember, common denominators, the bigger the numerator, the bigger the fraction. I have more parts shaded in. So I can say that 4/8 is less than 5/8, or up here, since 4/8 is equivalent to 2/4, 2/4 is less than 5/8. But let's see if we can come up with another way that we could find how these two fractions are related. So I'm going to start again with my 2/4 and my 5/8. Another way to get a common denominator is to multiply my two denominators together. When I multiply my two denominators together, how do I get my equivalent fractions? So equivalent for 2/4, when I multiply that by my other denominator, I get 16 over 32. Notice I multiply my numerators, I multiply my denominators. Now, when I take my 5/8 and I multiply by my other denominator, I get 20 over 32. And now, because I have common denominators, I can compare 16 30-seconds to 20 30-seconds. And of course, we're going to get the same result up there. Now I'm going to show you a shortcut. This is actually called the butterfly method. And it's a butterfly method because we are going to make a butterfly with our multiplication that we're going to do. So we multiply our opposite denominator to our numerator. We get 8 times 2. We know that's 16. And now we're going to draw our other butterfly wing over here. And we're going to multiply 4 times 5, and we get 20. Now, what we've essentially done is we've multiplied our denominators, which is 32, and all we have to do is compare those two numbers. 16 is less than 20. So shortcut, let me show you the shortcut, and I'm going to pick two new fractions for this. Let's use 2/6 and 2/6, then we'll keep 5/8. So this time, our fractions are 2/6, 5/8. Now, if I use the butterfly method, here's what I'm going to do. I'm going to take a shortcut. I'm going to multiply, cross multiply my denominator to my numerator, follow my arrow, 6 times 5, that number goes up here, 30. Then I'm going to do the opposite wing, going to multiply up, 8 times 2, and that's going to give me 16. And we know that 16 is less than 30, so 2/6 would be less than 5/8. So that's called the butterfly method. And what you're really doing is you're finding a common denominator, but we can kind of take this shortcut and just cross multiply denominator to numerator, and compare our numerator results.